Okay, so the important things with these, Liam, is that you're recognising what formula is required. Okay, and so the moment that you see a prism shape, we're talking about calculating things or the volume by saying area of cross section times by the height. Guys, I'm trying to explain something, please. Can you keep your noise down a bit? Area of cross section. So every time you're trying to find the volume of a prism, it's area of its cross section times by its height. Okay. Now you know it's a prism because we've got this shape down here and we've got exactly the same shape here. Alright? That's what makes it a prism. If it reached a point above the base, what would it be called? Pyramid. Absolutely, a pyramid. Good. So the moment that it's a prism like this, we do area of the cross section. I'd almost like to change it to say the area of the shape which makes your cross section. Does that make sense?
What's the cross section?
Yeah, that's right. Now your cross section, and I'll just finish this first, times by your height. Your cross section is, remember I said, imagine each shape as a block of cheese, and if you're to cut it any way, you're going to get exactly the same shape all the time. If I cut this shape through there, or I cut this shape through there, or through there, when I look down on it, what shape am I going to have regardless of where I cut it, whether I cut it up there, or through the middle, or down the bottom? What shape am I going to have when I'm looking down at it? Yeah, which is what shape? It's a triangle. Alright? With this shape, I'm looking here now. If I cut it through there, or through there, or through... what shape am I always going to get? I'm always going to get a 1, 2, 3, 4, 5, a pentagon. Yeah, a pentagon. So what we do therefore is we say, find the area of the shape which is your cross section. So on this occasion, the area of your shape is a triangle. On this occasion, the area of your shape is a pentagon. Alright? We'll come back to these questions, but I just want to look up a little bit further. Remembering what I've just spoken about there, if we go up a little bit further, the volume is area of the cross section. Well, if I was to look down here, what is the shape of your cross section? What is the shape? It is a circle. So volume is the area, it becomes area of circle. Yeah, let it catch up. Area of circle times by your height. Okay? Area of a circle, that's 2 topics ago. Area of our circle is pi r squared, isn't it? Pi r squared times by your height, 7. Pi times r, 4 squared, times by 7. Pi times 16 times by 7 gives you so many cubic centimetres. Okay, you all right with that? Is that giving you some clarity?
Yeah.
Right. Now, if I remove that and we go back to the question we were doing, what do you need in order to solve this one? The area of the cross section, the area of the triangle, and it's given for you. So with these ones, they're very simple, Liam. They're still the area of the cross section. It's just that instead of using your area formulas from the past times by the height, instead of using the area formulas from the past, they give you what the area is of that shape. Okay? This one here, they give it to you there. Let's go with this one here. Let's try D together. All right? The area of the cross section. Now, if I was to look here, And look there, okay, and if I was to cut this shape through there, or cut this shape through there, what shape have I got? I've got a triangle, okay? So volume equals the area formula of a triangle. What is that? No. Area of a triangle is half. Good finish. Well done. Half base times height. That will give me the area of the cross section. And then I'll multiply it by the depth or the height. Let's go 8. Half base times height, you half your base, which is 7, times by your height, and then multiply that by 8. Yeah? This one here attempts to trick you a little bit. You've got to work out where your cross-section is on all occasions. Okay? So that one's a bit tricky. But the rest of them, they'll either give you the area for you times by the height, or you've got to work out the cross-section there and move on from there. Okay? When, I'll finish in a sec, mate. When we are into pyramids, I'll just get rid of that. When we're into pyramids, which is there, okay, when we're into pyramids where they meet at the point above the base, all right, we are doing 1/3 times area of base times by the height, which is slightly different to what we're doing when they're prisms. All right. Can I explain that better for you, or is that all right? Yep. Okay, so to find the volume of the concrete required to make this ramp. Do you remember in our previous topic in area, often we'd have it was called a composite shape, and you had to find, I think there was a circle in there that came across the middle, and you had to find the area of that shape. Do you remember doing that? Remember doing that? This is a little bit similar. All right. I would be tempted to say I have a shape which looks like that. If I just get rid of this for a minute out of my head, put a hand over it, what I've got is a rectangular prism here. I hope you can see. Now, rectangular prism you should be able to work out the volume of. It's the area of the cross section times by the depth. Yeah? That should be relatively simple. Okay, or could be. Could be difficult. I'd find it difficult, but someone like you should find it easy. Could. Then you've got to decide, what do I have here? Well, I think if you were to continue this line, you would agree that you may have another rectangular prism. But you've possibly got how much of a rectangular prism? Maybe you've got half of that. Can you visualise that? Is that alright to visualise? Yeah. Yeah? You've probably got half, haven't you? Half there, whereas the other half would be there. So you could use the same process that you did here and calculate the volume of that, just divide that by 2, and then add that to that. Possible? Give it a go. Okay?